Okay, this is a three-part question. Starting with this first part, say that points A, B, and C and D have position vector A, B, C, D with respect to O. We want to show that M, the position vector of M on AC, that means there's a straight line M on AC, such that lambda AM equals to mu MC, where lambda plus mu is given by this one. This one we just apply the ratio theorem, okay? Because this can be rewritten as AM over MC equals to mu over lambda. So that we know that the AM is the ratio compared to MC is this and this. So Google for ratio theorem and see how it is applied, right? So this is my M. So to find OM, basically what I need to do to find OM or M, what I need to do is I take lambda. Okay, I take lambda here, multiply to OA plus mu here, multiply to OC over lambda plus mu. But since lambda plus mu here, it says 1, so therefore I arrive at my proof here. So okay, so then the next thing is how to deduce further that mod m square equals to this. So okay, realize, okay, for dot product properties, m dot m equals to mod m square is a formula, but of course you can prove it, but I'm not going to prove it here. You can, it's one of the formula when a dot a equals to mod a square, m dot m equals to mod m square, right? So then the m is equals to lambda a plus mu c, so I replace it dot product of lambda a plus mu c, right? So when then here we make use of the distributive rule of dot product, which means that it's a lambda a dot lambda a first, so lambda square, and then because a dot a is mod a square, then after that we have lambda a dot product mu c. So the scalar can, this is the what we call commutative rule for scalar, so they can move in front, the lambda mu, and because there are two of them, because lambda a dot mu c and then mu c dot lambda a, so there are two of them, so we have this, and mu dot mu c dot mu c, I get mu square, mu dot times mu square, and c dot c is mod c square. The next step, I'm just going to shift this to here and this to here, right? Nothing much. And then because I know that I'm going to improve eventually to here where there's no lambda square but just lambda, so I know that, okay, one of the lambda I must change to 1 minus mu. How do I know that this lambda is 1 minus mu? Because here we have lambda plus mu equals to 1, so that means lambda equals to 1 minus mu. Then same thing for here, mu equals to 1 minus lambda. So here this is essentially mu mod c square. I change one of them to 1 minus lambda. That's what I'm doing. Same thing for here, is lambda mod a square, and change one of the lambda to 1 minus mu, right? So nothing much here. So after I use the distributive rule again, so lambda mod a square minus mu lambda mod a square, minus mu lambda mod a square will be here, right? Then lambda mod a square is here. Then I have mu mod c square times 1, which is here, multiply by the mu mod c square I have here, and multiply by mu minus lambda mu mod c square. Minus lambda mu mod c square is here, right? And then I have the 2 lambda mu a dot c. Minus minus become positive. 2 lambda mu a dot c. So I have it here. So all terms accounted for. I move on. lambda mod a square plus mu mod c square, then I just realize that this is mod a square minus 2a dot c plus mod c square is just a minus c dot a minus c. Okay, you can try expanding out a minus c dot a minus, make it neat. So if I do a minus c dot a minus c, I should do it here, a minus c dot a minus c, if you do the distributive rule, you realize it is a dot a is mod a square, then minus a dot c, then minus c dot a, which is product property c dot a is equals to a dot c. You can switch around, and then after that minus c dot minus c is plus mod c squared, because minus times minus is plus, c dot c is mod c squared. So the minus a dot c minus a dot c is minus 2a dot c, which is here, right? So I'm simplifying this part. I'm factorizing this part into this thing, right? So the next step, I know that a minus c dot a minus c is just mod a minus c squared, just like a dot a equals to mod a square. So a minus c dot a minus c is equals to mod a minus c squared, just applying the formula. So then I have proven what they want me to prove, that so basically mod m square equals to this, which is here, right? So yeah, that's it. And move on to the next part. The next part says that show that if ABCD is a rectangle, then mod a square plus mod c square equals to mod b square plus mod d square. So we make use of three things. So first, we know that the property of a rectangle, the diagonals have equal length. So that means the mod BD equals to mod AC. Some students make the mistake of saying BD equals to AC. That is incorrect, right? It's the length that are equal. Mod means the length. Length of BD and the length of AC are equal. Or the distance of B to D and the distance is equal to the distance of A to C. Mod is actually the distance function. So BD equals to AC is wrong because they have different direction. First thing, they have different direction. Yeah, so it's not possible. So if the mod of is equal, the square of the mod, they are equal. So then remember, BD is just second minus first, so D minus B, right? D is OD and B is OB. So again, A dot A equals to mod A square, so D minus B dot D minus B is equals to mod D minus B square, and mod D minus B square is just BD square, right? So first thing, like D minus B mod square is equals to this, and this is equals to C minus A mod square. So C minus A mod square come here, become the dot product. Again using this the formula, right? C minus A dot C minus A equals to mod C minus A square is using this formula, right? And then after that, I just use the distributive rule. D dot D equals to mod D square minus D dot B minus B dot D. So B dot D equals to, this is another property. It's possible to commutate, right, for dot product. So that means since they are equal, I just minus them minus 2 times, so I get minus 2D dot B. Then minus B dot minus B is mod B square, again using this formula. And the other side is the same, right? So because I have minus C C dot minus A, so is minus A dot C, and minus A dot C here, so I get minus 2A dot C, and the rest you know. So another property of the rectangle is that the opposite sides are equal. So AB in this direction is equals to DC. Right? Do not make the mistake of saying AB equals to CD. No, they are not correct because the direction matters in vectors. So AB is just second one minus first one, so B minus A. Second one minus first one, so C minus D. So imply that my B minus C minus A is equals to minus D. Why I do this is because I need it for the later part here. I will have this B minus C minus A. I want it to become B minus D. So okay, because you see a bit backtrack. So we prove to here it is quite close to what we want. Do you see this? We have mod D square plus mod B square. We have mod C square plus mod A square already. So basically, if we can prove that my minus 2D dot B equals to my minus 2A dot C, then both of them can cancel off. And then I'll get my proof. I'll get this. So what I need to do now is just to prove that D dot B equals to A dot C. Then of course minus 2D dot B would become equals to minus 2A dot C, and they can cancel off. So I'm trying to prove this here. From the later two part, I'm using the properties of rectangle to prove that D dot B equals to A dot C. So now I've proven this. I move on. So B minus A, since AB dot CB, because this is the rule that say if AB is perpendicular to CB, then AB dot CB equals to 0. This is the rule. So if A dot B equals to 0, then A perpendicular to B, right? This is just the property, right? Nothing related to this question. So then why the question is, well, why don't I do AD dot CD equals to 0? Actually you can. I don't want to do it this method now. So I just use this, right? So then AB is B minus A, right? Then CB is B minus C, and again the distributive rule to expand it out. And I realized, okay, there's a B, B, and B here, 3B. So I factorize out the B for dot product. So because there's a distributive rule, of course I can like take it out. So then I'm left with B minus C and A inside, right? B minus C and minus A inside. So this thing become my minus D from the earlier part, right? And that means my minus B dot D equals to plus A dot C equals to 0, which means that if I move this over to the right hand side, I get B dot D equals to A dot C. Then since I've proven that B dot D equals to A dot C, minus 2B dot D, I move it up for a while, minus 2B dot D would be equals to minus 2A dot C, right? So they will just cancel out, and then I've shown what they want me to show. Okay, so that's it. And I'm going to move on to the third part of the video. But in case it's too long, I'm going to show it in another link in the description below.